This is being recorded. Eunice is going to come up and actually teach the rest of the class from right here on this point right now. 6 notes. All we're doing is looking at it. We're going to make our own equations. They're going to tell us what the parent function is. Focus on the one that is solid. The other ones are just sort of there to sort of highlight what it would look like if it continued. But really, when we do a test, we're just going to do that one. Notice there's no vertical asymptotes. What does that take away? No vertical asymptotes means? It's not tangent. It's not cotangent. It's not secant or cosec. We just got to figure out everything. Can you figure out what the amplitude is? What I would do is probably draw the midline going across. What's your amplitude, peeps? 3. What's the period length if it starts here at pi over 2 and ends at 3 pi over 2? Pi. All right, think about that. Is there a reflection? That means upside down. Yeah. It's asking, is it upside down? The answer is yes. Is there a phase shift? That means left and right. Yeah, what's the phase shift? Right. Pi over 2. Right pi over 2. Is there a vertical shift? Up 1. Up 1. So it's going to be an up 1. Now, these two are tied together, this period, this one, and this phase shift, because when you do a period and a phase shift at the same time, those are the problems where you had to sort of distribute into parentheses. We actually did sine and cosine before, but now we're going to do some tangent and secant. All right, so let's talk about this. It's going to be y equals, obviously. What number goes first?
2.
Not even 3.
Negative 3.
Negative 3. Negative 3 is the right call. Negative 3 is the right call. Don't you be making fun. I know who's saying. All right. Negative 3 and sine. Okay. Negative 3 and sine. And we're going to take that number that is the, we got to figure it out. We got to figure out what that B number is. Let me figure out where I'm going to write that. So what's the normal period length? For sine, normal period length is 2 pi. 2 pi. And we're going to divide that by a B number, and it had to come out to equal pi. All right, so no need to like do algebra work. We can all see that it's going to be a 2 there, right? What you do to do this is put a 2 here, and then you start parentheses, and then you do your shift. If I want it to go right pi over 2, I write in there minus pi over 2, close it, and plus 1. All right. There are some times when you look at videos online, there's teachers that have told them just leave it like this. I like to distribute that too, make it look official. We're going to distribute, boom, boom, and our equation will be y equals negative 3 sine, and then what's the rest? 2x minus, what happens when you go here times here? That's the important part. This one times this one. Think about it. It'd be like 2 over 1 times pi over 2, although negative. Well, you wouldn't write 2 pi over 2. You just write pi. Bam, we got our equation. And that is what today's lesson is going to be like. I'll tell you right now what's going to be the tricky part is we're going to be doing this again and again and again. The tricky part will be when it's tangent and cotangent, what's the period?
Because when you set this on 0.
Pi is the period. You do need to tone it down a little bit. No, there's too much giggling. It's starting to become a distraction. That's all. Not a big deal. Not a big deal. All right, cosine. Cosine, you ready? Amplitude. Well, where's the midline in this one? It's not as obvious. Negative 2. Okay. Negative 2 is your midline. So amplitude. Sure, keep it on screen. Amplitude is going to be what?
3.
It goes 3 up from the midline, 3 down. So the amplitude is 3. Period length.
2 pi.
It is 2 pi. Is there a reflection in this one?
No.
No. That means no negative in front. Is there a phase shift left and right?
Left 2 pi.
All right, it's going left by 2 pi. Is there a vertical shift up or down? Down 2. If the period stays the same, the B number is a 1. And I don't have to worry about how I got to distribute that B number. If it's 1, it's just going to go, we can go straight to the parentheses. So there's no need to do anything on the side. I just go Y equals. Anybody want to take a shot? Toby? Write it.
Y equals
3 cosine parentheses. If it's 1, you don't need to distribute the 1.
Okay, x minus 2 pi.
Yep, there's only one little mistake. To make it go to the left,
Oh, plus.
we can do a plus 2 pi,
Yeah.
and then down 2. All right, how do we feel about these? All right, now, time out. Well, actually, you can turn the page. But think ahead a little bit. Eventually, we're going to get secant and cosecant. You don't even pay attention to the parabola stuff. You just look at where the ghosts would have been for sine and cosine, and then that helps you make your secant and cosecant. Now, they're probably going to have us practice a tangent or cotangent. We got to think about that. There we go. Holy cow. All right, what do you notice about this one? Well, they tell you it's tangent. But if I didn't have this, I would have guessed cotangent. I would have guessed cotangent because it's going down and to the right instead of up. All right? So that tells me it's reflected. It's upside down, so I can do that right away. Yes, it's going to have a negative. It turned it upside down. No, I noticed something else. Super wide. It's really wide. What's the period length of this graph? Going from here all the way to here.
Infinity to infinity.
No, that would be like the amplitude part. How wide is the period from here to here? 4 pi. To make it wider than normal, what usually happens in our equations? We talked about it during the homework. What makes those things go wider? What's that?
Fraction.
A fraction. A fraction. I didn't hear what you said there. Phase shift? A phase shift, no. A phase shift makes it go left and right. That's like in the last one we said plus 2 pi, that made it go, that's a phase shift. What stretches it like that wide or shrinks it narrow is when you multiply or divide with the x number. All right, amplitude. A little bit tricky, but can you figure out, oh, actually there's none. Never mind. We need to know the amplitude. Does it have a stretch factor number though? So it's always none because of tangent cotangent, but is there a stretch? All right, does everyone see what the middle number would be? Where does it twist? Right here at -0, -1. Okay? What does that tell you?
It goes down.
Goes down 1. Is there a shift to the left or the right?
No.
No. Well, yeah, technically no. Technically no. We're going to go y equals. Now, could you tell what would be halfway in between here, the middle, and here? What's halfway in between?
Negative pi.
Negative pi. And what's halfway in between here and here? All right. Now, what's important about that is that will tell me what number goes in front. Now, with sine and cosine, we call it the amplitude, right? We call it the amplitude. It's not technically the amplitude because it goes to infinity, up and down. But this will tell us what's the stretch factor number in front. What's the number in front? It's the distance from here to here and here to here. The stretch number in front is technically just a 1. Then we put tan. Oh, I forgot the negative. You're right. Negative. Forgot the negative. You've got to flip it upside down. It's going to be a negative tangent. We need to make this wider, right? You take your normal period. What's our normal period number?
Pi.
Not 2 pi. Pi divided by b has to come out to equal what? 4 pi. What's the b number? 1/4. 1/4 is the b number. So it would look like what?
That's over 4.
X over 4, and then we got y equals negative tan. The 1/4 is looking like this, like a little invisible 1/4. Close it, and then minus 1. You guys got this one? Gage, get off your phone. All right, we good? Let's try another one. Cosecant. We have to remember, cosecant is the ghost or the inverse of, not even inverse, reciprocal of. Yeah, I should write that down. I keep using the wrong word. It's 1 over, wait, someone say cosine? It's not cosine. This one's sine. 1 over sine. All right, now what I'm going to do is, let's draw what it looks like as they don't have it drawn in. We got to kind of picture this. It would go up here, through here, and here. Technically, for secant and cosecant, there's an amplitude that is undefined. But we're going to say amp of sine. That would give us our stretch factor number that goes in front. All right. So what do you think that number is going to be in front? Midline would be here. That number in front is going to be 3 up from there, 3 down from there. So it's going to be a 3 in front. Will that 3 be positive or negative? You look at the sine wave to tell. Will that 3 be positive or negative?
Positive.
It'll be positive, so there is no reflection. Is there a phase shift? Yeah. It goes how far in what direction?
Left.
Left.
3 pi over 2.
Yeah, 3 pi over 2. It goes left 3 pi over 2. Is there a vertical shift? None. And I forgot this part. What's period length? From 3 pi over 2 to just pi over 2.
2 pi.
Stayed 2 pi. So what's nice about that is the b number equals 1 if it stays 2 pi. Anybody want to try? You have it already? Jose, you got this one? All right, you say it.
Oh, wait, no, I
All right, I want you to give you a chance to look at it. Now, what's nice, it's not as tough as some of the other ones we've done because I don't have to worry about there's not a phase shift and a period change at the same time. Then you got to worry about distributing and all that. My distributing would be the number 1. So, all I need to worry about is the parentheses. Okay.
Let's start with 3.
Yeah, you got to start with a 3. Right? That's the amplitude for the sine wave, but it's the stretch factor for our graph. All right, keep going. Cosecant, parentheses,
X
plus 3 pi over 2. That's it, right? And then if there was any shift up or down, we put that after it. That's not so bad. Akil, you getting this? Why you look like you're Googling for it on your phone? Come on, you did already? All right, you're gonna help lead me in this one. All right. Well, very nice. They put all the graphs in there. They didn't have to do that. All right, we're focusing on the one that is solid. Your homework's going to look that way as well. Let's highlight some points. They tell us it's cotangent. First of all, is it reflected? No. All right, we can fill that in, right? It's not flipped upside down. The period is going to go from, the period we're looking at goes from pi to 2 pi. How long is that? It's pi. Before it starts repeating itself. Right? It's just pi. Now, what's the normal period length? It's pi, right? So what does that tell you? Yeah, the b number is a 1. So again, we don't have to worry about distributing it or anything like that. Amplitude is technically none, but is there a stretch factor number? We got to figure that out. So can you tell where it twists? 3 pi over 2 and what number? At 2. So definitely there is a vertical shift up 2. Vertical shift up 2. There's a phase shift to the right You say 6? That's odd. Why do you say 6?
Oh, sorry, 3 pi.
3 pi over 2. There's all pi's out there. If they canceled pi, they'd stop doing that. If they cancel pi, that would make it a more difficult problem. All right, now, it goes 1 up. It goes 1 down. What's the amplitude or the stretch factor number? 1. All right, so there's a whole lot of not having to worry about this stuff. This could have been a little more difficult. Gage, it's all yours. Y equals.
Cotangent. Wait, is there,
I was going to ask you, is there a number in front?
is there just 1?
Yeah, it's just the normal stretch factor of 1, right? So you don't have to write 1. Cotangent.
Parentheses x minus 3 pi over 2.
I like how you did minus because that makes it go to the. Wait. Where does cotangent normally start with an asymptote? Does it start at 0 or does it start at negative pi over 2? Yeah, I just realized when we made these problems up, it probably would have been smarter to do a phase shift with tangent because it starts at negative pi over 2 and then you have to figure out. Now this one's kind of easy to tell. Normally if we do cotangent, I'm going to sketch it up here. If we do cotangent, it's here and here and then you have your twist, right? So we could tell it moved over, it just moved over by pi, not 3 pi over 2, it moved over by pi. Wait, that means I answered this one wrong. No wonder you said that. No wonder you said that. What's that? It did move over 3 pi over 2. That twist point is normally at pi over 2. It moved over by pi. This twist point is normally at pi over 2. Now it's at 3 pi over. It moved over by pi. Sorry, I should have caught that the first time. No wonder you said 3 pi over 2. All right? So what should be in here?
Pi.
Just pi.
And then parentheses plus 2.
Plus 2. Got it. GG. I know I flubbed that one a little bit, but are you getting this?
Yes.
All right, I want everybody to try the last one. Some kids already did it, but if you haven't, try it right now. Take a couple minutes and try it. Secant means it's going to be, you need to ghost the cosine wave in there. And I noticed something right away. Is this one reflected, yes or no? Is that a little flash of lightning there? Did I just see? Like in the distance? No? Alright, it's just my old man eyes. Bert Kemper, how we doing? Oh, you're not getting? Alright. I'll kind of guide you through this one. Can you see where that cosine wave would be? Alright. So, it would kind of go, it's upside down to begin with, okay? Because the point is here. So instead of being up, it's down. It hits here, and here, and here, and here, and here. So it kind of looks like this. Can you picture that? So I'm using those key points. Those asymptotes are kind of key points as well. That also shows me where that midline is. Didn't move up and down, right? So there's no plus or minus at the end of this equation when we get to that point. What's the period length, though? How long is it from beginning to end?
4 pi.
It goes from 0 to here. Now, technically, for secant and cosecant, your answer is there is no amplitude, or you put undefined for amplitude. But is there a stretch factor number involved here? Is there a stretch factor number involved? You would look at the amplitude for the cosine wave to tell. Is there a stretch factor number? Yeah, it's 1. So you don't have to worry about putting a 1 in there. Stretch factor, because from the midline, here's my midline, it only goes up 1, down 1. It's just got a 1 in front. But technically, I guess we could say -1. It's going to flip upside down. Is there a phase shift, left or right? Does not shift it left or right, no. That means no add or subtract in the parentheses. Is there a vertical shift, up or down? I gotta say, they took a whole lot of the stuff. This isn't nearly as tough as I would. All right, class. What do we got? Oh, I'm sorry. I thought it was a little easier in my head. I was thinking 2 pi, but with this 4 pi, we do have to figure this out. Period is normally what for cosine? 2 pi. So if you picture 2 pi divided by b and it comes out to equal 4 pi, we got to figure out what that b number is. So one of the things, I think I started in the class after yours. Watch this. This might make it easier. You put 4 pi over 1 and you just cross multiply. And you go, all right, 2 pi times 1 equals 4 pi. I'm going to put a little times that, times b. When you divide 4 pi, the pi's cancel, and it gives you your b number, which is 2 over 4. The b is a half. This is especially, I think most of you figured out it was a half because of that 4 pi. It's happened a bunch of times. But let's say it was more difficult. Let's say it was 1/8 or 1/4 or something like that. 1/6. You probably want to do this little cross multiply solve for b type thing. All right, PreCalc. I kind of laid it all out there for you. What do you think?
Y equals, I put the minus sign.
Yep.
And then I got secant, and then parentheses x over 2.
Perfect.
And
That's it. That's all there is to it. All right, you got it? All you kids on a field trip, you got to watch this video. Take the notes. You got to be ready. What are we doing next class period? Yeah, I'm going to go over this, and it's not going to take long to go over it. I'm going to go over this, and we're taking the group test. That'll act like review number 1. I'm going to grade those quick. And then the next class we meet next week is your review, official review day, but you'll get the group test back. Group test will be like a dry run. And then shortly after that will be the beginning of the week before spring break. And that beginning of the week before spring break is going to be where we have our unit test over all this stuff. Any